Here's an interview question from Jane Street. What is the distribution of the sum of two independent uniformly distributed random variables? Formally, if x and y is uniformly distributed between 0 and 1, what is the distribution of z, which is the sum of x and y? So this question tests your understanding of convolution. Now, if you're not familiar with convolution, don't worry, I'll give you a brief overview. That would be enough to solve this question. So let's see how we shall proceed. We are given x and y are independent, uniformly distributed. The PDF of x and y is given by this function here. F of x is equal to f of y is equal to 1 if x is between 0 and 1 and 0 otherwise. So if you try to visualize this, you have the x-axis here. If this is 0 and this is 1 and this is 1. So for all points between 0 and 1, it's 1 and 0 everywhere else. So as I mentioned, this would involve the use of convolution. The sum of two independent random variables has a probability distribution given by the convolution of their individual distributions. Now, this might sound a little complicated, but I'll try to simplify it as much as possible in case you're unfamiliar. Consider our random variables on these axes, x and y. They are both uniformly distributed between 0 and 1. So we have 0 here and 1 here. And this is our square. Now, we are given that z is equal to x plus y, where z is another random variable. Now, for a moment, consider any value of z, which we denote with small z. What would this look like? This would be a line something like this. Now consider point x on the x-axis here. This blue line is our line x plus y equal to z. So if this point is x, the corresponding y coordinate, y point would be z minus x from this equation. Now our PDF for x was f of x. So what will be the PDF at this x? This would be f of x. And what will be the PDF at this y? This would be f of y z minus x. Now, what will be the total probability that x is equal to x and y is equal to z minus x? Will be the product of these two. Now, this product would be f of x times f of y z minus x. Now, of course, uh, this x, we have to calculate it over all of x, not just a single point. So this will have to be integrated dx from minus infinity to infinity. And this would give us f of z. Now this is what convolution is. Now I should point out that there are some nuances which I skipped just to keep it simple, such as that we don't really calculate it. The PDF is not calculated over a point. F of x would technically be 0. It should be probability that this width should be dx, and I should state that we are calculating the probability that x is between x and x plus dx. But overall, this is what the idea behind convolution is, and this is what we'll use to solve this problem. So we have f of x, we have f of y. All we need to do is uh, decide calculate the range of x and z, plug it in, and then integrate it to get the final answer. So let's see. So to recap, we had two random variables, x and y uniformly distributed between 0 and 1. The PDF of x and y is given as 1 when x is between 0 and 1 and 0 otherwise. And the convolution of two random variables is given by this equation over here, and we just saw how this equation comes to be from a visual perspective. So f of z is the convolution of these two random variables x and y, and this is the integral from minus infinity to infinity f of x times f of y z minus x dx. So now we have to integrate this based on the range of x and z. So the equation we have is f of z is equal to integral minus infinity to infinity f of x times f z minus x dx. Now, both of these are uniform random variables. So this, the product would be either 1 or 0. It would be 1 when both of them are 1, and if either one of them is 0, the product would be 0. So when would it be 1? As we saw for a uniform random variable, when this x over here is between 0 and 1, then it would be 1. So x is between 0 and this z minus x is also between 0 and 1. Only then would it be 1. So the first density requires x to be between 0 and 1. Second density, this one, z minus x, requires it to be between 0 and 1. So these are the two inequalities which we have to solve uh, to find the range in terms of x. The first inequality, we already have it in terms of x. We don't need to solve. The second one we had was z minus x is between 0 and 1. So we multiply this with minus 1. This would flip the sign, and then we add z. So this would give us z, z minus 1. So x is between z minus 1 to z. Now, we have two inequations for x. We have to combine both of these. So how do we combine it? So let's say the first equation. So the first equation says x is between 0 and 1. The second says it's between z minus 1 to z. So z minus 1 to z. Now to combine this, our x which should come out from these two should be the one that's common for both of these ranges. So if we are taking the example of this, let's say these are on the same scale, on the same axis. Uh, this one is saying that x ranges from here to here, and this one says x ranges from here to here, right? So what's the common part? This part is the common one, which means this would be our x. Now, how do we write this uh, of in terms of z? So take take the first part. So we have 0 here, and we have z minus 1 here. The starting point would be the maximum of these two. So if you see in the example we saw here, our 0 was further ahead of z minus 1. So that's why our answer starts from here. It starts from 0, and then it goes till here, z, which is the minimum of 1 and z, which is what we have written here, minimum of 1 and z. So this is our general answer for x. It's the maximum of the starting point of both of these range and the minimum of the ending point of both of these range. So what does our integral become? So if you recall, we had the integral from minus infinity to infinity, but we just calculated the range of x, and the general answer said that x would range from max of 0 to z minus 1, and the upper limit was min 1 comma z. And we had the PDF function here, product of the PDF, but as we uh, discussed, the PDF would be 1 because we are calculating it over the range where the PDF product is 1. Otherwise, if any of those PDF is 0, it would be 0. So this is what our uh, PDF would look like. Now, this is the general form. Now, to calculate this, we have to unpack the range here, which is in terms of max and min. So, what do these range uh, mean? Because we can't really integrate unless we have some values. So max from 0 to z minus 1. So now we have to check how does this change when z moves from 0 to 1 to 2. So z was a sum of x and x and y take value from 0 to 1. So z can take value from 0 to 2. So when x and y are both 0, it will be 0, which is the minimum, and when x and y both are 1, z would be the maximum, which is 2. So z can take values in this range. Now, when z is less than 1, so we have 0 here, then 1 here, and then 2 here. When z is less than 1, which is this range here, the lower limit of the range, this part max 0 and z minus 1, z minus 1 would be negative because z is less than 1, which means the maximum of these two would be 0. And the upper limit, which is the minimum of 1 to z, this would be z because z is less than 1, which means the range would evaluate to 0 to z, which means the integral would evaluate to this 0 to z, PDF1, integrate it, and you get z. Similarly, when z is greater than 1, which means in this range, this part z minus 1 would be greater than 0, which means the max would evaluate to this second term here, which means this max is z minus 1, and the min of 1 and z would be 1 because z is greater than 1. So the integral limits would evaluate to z minus 1 to 1, and integrating this we get 2 minus z. So what do we have so far? For z between 0 to 1, we had the range of x from 0 to z, and for z between 1 and 2, we had the x range from z minus 1 to 1. So now we put all of these values. We The first part of the range was z between 0 to 1, second was z 1 to 2. For this part, the integral became 0 to z 1 dx integrated to z. Second part, z minus 1 to 1, this gave us 2 minus z. And then this gave us the final PDF, which is the final answer. PDF is z for z between 0 to 1 and 2 minus z when z is between 1 and 2 and 0 otherwise. So this is the final answer, and the distribution is triangular. If you try to visualize this, so you would see something like this. It would increase from 0 to 1 and then decrease from 0 to 2. The peak is at 1. So this is the final answer, and this is the solution to this problem. You can, if you want to read similar problems, you can check out datalooper.com. Thanks for watching, and I'll see you in the next video.